Okay, guys, so here is a little like kind of setup about what we're going to be doing today in class. We did this the other day. This is kind of um, for those that weren't available or didn't watch it, what we have here is a dynamics cart. It's awesome. And we have a track here that has grooves in it. On the track, there's a whole meter stick that's kind of laid out there. I have a binder here at the end. And at the other end, I have this little sensor that's going to measure how fast this cart is going down the track. So we're going to do several trials. We're going to release the cart from 40 centimeters, do 3 trials to see how fast it goes and to also see how far it's going to push the notebook. Okay, so I'm going to give you like one go through without actually seeing the data, just so that you know what's going on. And then I'm going to switch over to the program that I use to gather the data. And just in case that you lose like the video, you'll at least have this to see what was going on. So what we're going to do here is we're going to start it at 40 and we're going to let it go. And we're going to measure how far, oh, they like to fall off the table too. We're going to measure how far that cart pushed the binder from the end, from our beginning mark. So that's kind of what we're going to be doing. I did it from 40, we're going to do it from 60, and we're going to do it from 80. Okay, so now that you kind of see what's going on, it's not very exciting, other than watching me scramble to try to keep the very expensive cart from falling off the table. So what I'm going to do is I'm going to share my screen with you. And this is kind of where we're at here. So this is the program that we're going to use to gather the data. So let me set up my notebook in the appropriate spot. You have to make sure that it's like dead on here and straight. And so this data that we're going to collect, it may take me a couple of times to get it so that it's consistent. But we're gonna give it a try. So here we go. So at 40 centimeters, let's get it on the track correctly. So the front of the cart is at 40 centimeters. And what I'm gonna do is I'm gonna click collect, and then it's gonna make a graph here that you can see. And then I'll show you what the maximum speed was, and then I'll measure it. For each, this is going to be in table 1 of your lab, a crash course. And this is trial 1 at 40 centimeters. So here we go, fingers crossed. Okay, not bad. So we got a nice graph here. Let's see, clicking here and viewing statistics. So the very first velocity is right here, 1.011 meters per second. Hold on, let me get a piece of paper so I can write it down. And something to write with details full. Okay, sorry about that, guys. Oh, that is crooked. Let's make that a little straighter. Maybe it will end up being better. Okay, so the first velocity for the 40 centimeter start in table 1 is 1.011 meters per second. And the distance that the notebook moved was, stop rolling, there you go, was, dead fly. Was, where's my little mark? There it is, 14.5 centimeters. 14.5 centimeters. So the first trial The velocity is 1.01 meters per second, and the distance is 14.5 centimeters. Okay, that one seemed pretty good. Let's see if we can get another good trial. Okay. So again, we're starting at 40. Getting it in the little slots. Let's see if we can collect that. Oh, let's see if we got anything decent out of that. So that was 1.009 meters per second. So that's trial 2 for 40 centimeters in table 1. And the distance that the notebook moved was 16 centimeters. So 16 centimeters. Okay. 16 centimeters. Okay. Well, those were 2 okay ones. Let's see if we can get a third one here before it goes wonky on us. Okay. Okay, not bad at all. So let's take a look here. So this one is 1.017 meters per second. And it moved the notebook 16.5 centimeters. 16.5 centimeters is how far it moved the notebook. Okay, so that, oh gosh, things are like a bull in a china shop. 16.5 centimeters. And so that takes care of our data for table 1. Now we're moving to table 2, which is starting the cart from 60 centimeters. So let's see how that's going to work. So everything's all lined up here. Okay, we're at 60 centimeters. Okay, and again, that looks pretty good, although it's making a break for the end of the side of the table. So what do we got here? Now it's 1.193 meters per second is trial 1 for 60 centimeters. And how far did it move the binder? Binder moved 20.2 centimeters. So the first trial is the distance is 20.2 centimeters and the velocity is 1.193. Okay, let's give her another try. Oops, I gotta fix my binder here. Make sure it's square. Okay, 60 centimeters, trial 2. And that one, I don't know why they colored some different color every single time. This one is 1.206 meters per second. And how far did it push the book? Let's see here. It pushed the book 22.5 centimeters. 22.5 centimeters. Okay, so the second trial for the 60 centimeters start position is 1.206 meters per second, and the distance is 22.5 centimeters. Okay, last trial here. Make sure we got them on there where we want them. Okay. right there. Okay, apparently it doesn't want to stop. Okay, just put it right there. And our velocity is, for the third one, is 1.204 meters per second. So that's the velocity of the third trial. And how far did it move? It moved 21 centimeters. So 21 centimeters even. Okay, so that takes care of our 60 centimeter position data. So now we're going to go to 80 centimeters. And this one should by far be the fastest because it's going down the ramp the longest. Okay, so this one's going to be a little tough. All right, here we go. Whoa, we lost the, when it hit the ramp, when it hit the end of the ramp, it lost its little thing on the back. Let's try that one again. Line up my binder again for a good shot here. So let's collect again. Okay, not bad. I really need to do this on a table that has sides on it. Okay, so what did we get for velocity there? It's 1.307. So table 3, trial 1 is 1.370 meters per second. And the distance that the binder moved is quite far. It is 24.5 centimeters. 24.5 centimeters is the distance that the notebook moved. 24.5 centimeters. Okay. One more trial. This is going to be trial 2 at 80 centimeters. And so stay right there. Trial 2, the velocity is 1.387 meters per second. And the distance that the book moved is oops, let's turn it around here. So it's 24 even. 24 even. 24 centimeters is the distance for trial 2 under 80 centimeters. Okay, let's put the book back. And let's do one more, and that will be the last trial. And this is actually going quite well. Don't fall off there. Okay. So our velocity for that trial is 1.375. It's good data, guys. And how far did the binder move? I would say 25.2 centimeters. 25.2 centimeters is the distance for the third trial. 25.2 centimeters. Okay, so now that you've seen the lab done, you've got the data. Now, a couple of things. When you're answering the next thing that you need to do is to take the speeds from each data table and average them together. You're going to add them up and then divide by 3. And then you're going to put that number in data table 4, and you're going to do that for each speed from table 1, table 2, table 3. And then you're going to do the same thing with the distance. Table 1, table 2, table 3 is all going to end up, the averages are going to end up in table 4. Make sure you show me work on how you did it in that data table as it says in the directions. Then what you're going to do is you're going to take those, that data from the averages, and you're going to use it to answer the questions, particularly questions 2 and 3. And I think there's one more question there where you have to supply some data. On those questions, if you don't supply the data to support your claim, you're going to lose big time points. And don't just say the data shows. Well, what about the data shows? You have to use actual numbers. If it asks you to support your claim using data, make sure you actually use numbers. If you don't use numbers, you're not going to get full credit for that. As a matter of fact, a claim without any evidence to back it up, not worth a whole lot. Okay, so I'm pretty much done with this lab. Thanks for tuning in, and hopefully I'll be seeing your finished lab report soon.